Hi everyone. So today this is going to be our first video, and this is looking at physical geography, and we're going to be focusing on coastal landforms for this first session. Okay, and with that in mind, these are all the things we're going to cover. We're going to cover coastal processes, so types of erosion, types of transportation and deposition. We're going to look at erosional landforms and the best way to tackle those. And then we're going to look at a couple of depositional landforms as well. And with that, you need to be able to draw them and be able to explain them to answer a geography question in the exam as well. So first things first, in order to understand how different landforms are created, you absolutely need to know the main processes involved. And there are four types of erosion. We've got hydraulic action, which is basically hydra means water, doesn't it? So it's just the sheer force of the water eroding the cliff. So imagine a big wave smashing into a cliff. If you want to go one step further, you can tell your examiner that the air becomes trapped in the cracks and expands and breaks down the rock. Okay, so that might be used to turn a crack into a cave, for example. Then we've got abrasion. When the wave hits the cliff, it's going to be carrying material, little bits of stones and pebbles and sand. And as that gets thrown against the cliff, it's going to wear it away like sandpaper as well. We've got attrition, which is just rocks hitting each other, become smaller and smoother. Eventually, that's how we get pebbles and then sand. And we've got solution. Just think of chemistry in school, solution, acid. It's just the dissolving of material with the acidity of the seawater. Now, that's quite a lot to remember. So I tell my students, if they're only going to remember two, to remember hydraulic action and abrasion, because these are the ones that are really doing the damage. Attrition, rocks hitting each other, is not doing a lot, and solution is quite a slow process. So I would definitely, if I was going to learn just one or two of these, definitely learn hydraulic action and abrasion. And we'll see why they feature soon and why they're important. Then we've got our transportation processes. This is basically how material is carried in water. So larger rocks are rolled, and that's called traction. I think of this as large rocks rolling along the seabed. What helps me remember that is a tractor. Traction, tractor, wheels roll. So traction, tractor, large rocks rolling. Saltation, if I was to bounce salt on my table here, on my desk, it would bounce. So saltation is just small stones bouncing. Suspension, if you're being suspended, you're hanging in the air. This suspension is small material just floating on top of the water. And then solution is the same in terms of the type of erosion. It just involves that dissolved load that we talked about earlier, being carried in the water. You can't really see this happening. It just makes the water look quite murky. Okay, so it might be that solution is working in moving, transportation processes are moving sediment along the coastline. So suspension, for example, saltation, and that's where longshore drift comes in. So all that eroded material gets carried towards the beach. Now, the main factor in the formation of waves is wind. In the UK, our prevailing wind comes from the southwest, and you can see that that is the same angle as the swash. The swash is just another term for a wave washing up a beach, and it's exactly the same angle as the prevailing wind, so you've got to get that in there. And then the backwash comes straight back down at a 90-degree angle, and that's due to gravity. Okay, and then that just continues, and the waves are going to be carrying sediment all along the coastline, and that is our direction of longshore drift. Okay, so in this case, it's moving from left to right. And I just say to students, if I was to kick a football into the sea, you watch the waves bring it in and take it out and bring it in and take it out, and it's going to be moving along. Okay, deposition, this is why sand or sediment gets dropped, and generally, as we said earlier, wind is what create waves, and that gives them energy. And if I was carrying some weights or some rocks and I lost my energy, I would drop it. It's the same in the sea. So if the waves lose their energy, they are going to drop what they're carrying. Okay, what might stop them from having energy is the fact that you might have something called a headland, which we'll look at in a second. That could be blocking the wind, the prevailing wind, and therefore it's sheltering it in the bay. Just think of, like ships sort of harbouring in a bay for shelter from the wind, and then the sediment's going to get dropped in there. As the beach approaches, as the wave approaches the beach, there's going to be friction between the bottom of the wave and the seabed. That's also going to cause it to slow down and deposit its load. Okay, and then finally, if the coastline changes direction as well, that can cause sediment to be dropped, and we'll look at why that's important shortly. Landforms then. So there are quite a few coastal landforms that students need to know about. And with this, they need to be able to draw and label a diagram to show the formation. They've got to get the processes in there, such as abrasion or hydraulic action, and they've got to explain that process. If they just mention it, they're not going to get full marks. They have to say hydraulic action turns a crack into a cave. With the shear force of the water, air becomes trapped and expands and breaks down the rock. Okay, and it's got to be in the correct order. Okay, that's what the examiner is looking for. And to help you remember this might be worth writing down. We use something called PEST, okay? Processes, explanation, sequence, and terminology. So mentioning those processes like hydraulic action and making sure we explain what hydraulic action is, making sure we write the whole thing in the correct sequence, and making sure we use other key terms. Okay, so we're going to talk through some of these landforms now. So headlands and bays. Generally, the coastline didn't used to look like this, but what we have here is a mixture of hard rock and soft rock running perpendicular or at right angles to the coastline. So originally there would have been some soft rock here and some soft rock there, maybe some clay, but then we've got hard rock left jutting out into the sea. So the destructive waves attack the coastline, and those erosional processes that we mentioned earlier are going to break down the soft rock first, and it's going to leave behind this hard rock sticking out. Okay, you can tell it's hard rocks. It's got things like stacks here, which we'll talk about shortly. Inside the bay, this is a great photo to show it, because again we talked about there's the boats harbouring in there. There's shelter. It's calm in here. There's not really many waves, so they've lost their energy. So they're going to deposit their sediment at the back of the bay, and that's why we've got a beach in here. Okay, another reason we've got deposition. As the waves crash into this headland, the waves are refracted, which means they're bent round. And again, you can see this perfectly here. That's called wave refraction, and that's going to deposit the sediment at the back of the bay and form a beach. Here's another diagram. This is one that the students could draw. Apologies, it's a bit blurry, but there's our layers of hard and soft rock that we were talking about. So you might have clay as a soft rock. You might have like a hard rock, like a limestone or a chalk. Okay, this is a really good keyword, a discordant coastline. Okay, a discordant coastline. So headlands and bays form on discordant coastlines. And then after years of erosion, this is what it looks like. Okay, so here's our headland sticking out, and this is our bay, which will have the beach at the back. Next landform, it's called a wave cut platform. Again, any of these could be a 4 marker, a 6 marker. They need to know all these landforms. A good example locally to where I live on the Jurassic Coast is Kimmeridge or Dancing Ledge. And again, just imagine the cliffs come all the way out to here. Okay, the sea attacks the base of the cliffs, creating what we call a wave cut notch. So if we just fast forward to years of erosion, we're over here. Okay, you can see there's a bit of almost like a cave looking shape, okay, a concave shape, and that's where it's created a wave cut notch. And the size of this notch is determined by tidal range. Okay, so depending on how high the tide gets, depends on how big the notch gets. So it's going to be undercutting the cliff. And again, due to those processes, hydraulic action and abrasion, that's going to get deeper and deeper into the cliff. You're also going to have some weathering on the top, things like freeze-fall mechanical weathering, where the rainwater gets in the cracks and freezes. You're going to have some biological weathering. You can see that here with the plants. You might even have some chemical weathering with the acid rain on the top. And all of those processes on the top, okay, and the subaerial processes and the marine process down here, they're going to cause eventually this cliff to collapse into the sea. So imagine the cliff's collapsed over here. Same process repeats. The cliff retreats, and eventually you're left behind this massive wave cut platform. Okay, so that's it in action there. In sequence, sea attacks the base of a cliff. Okay, we get a wave cut notch determined by tidal range. Weathering on the top, cliff collapses, okay, revealing a wave cut platform, and the process just keeps on repeating and the cliff retreats inland. Next one is formation of a stack and stump, like Old Harry Rocks, again on the Jurassic Coast. Jurassic Coast is a fantastic example. If you go on Time for Geography, there's some brilliant videos as well, which really show this in motion. But again, this is a headland. So originally this would have been a massive headland. It's called Old Harry Rocks because Harry Pay, famous pirate in Poole, used to hide his ships behind here for passing sailors. And then he would take full advantage of that hiding spot and come out and do his piratey thing. So again, that's just to show that we're inside a bay here where it'd be a lot calmer. You can see the wave refraction happening there. So in order for this to be created, let's just focus on this stump down here. Okay, this would have been a big headland, and inside the headland you would have had some erosion, which would have formed a crack originally. So inside here now there'll be loads of cracks in there. That will get deeper over time due to those processes like hydraulic action and abrasion to form a cave. The cave will eventually carve all the way through to form an arch like Durdle Door, which is around the corner. And eventually the arch, let's just say there was an arch here. Again, because of those processes at the bottom and on the top, the weathering, the arch is going to collapse. Okay, so there would have been an arch here as well. And that arch has collapsed to form a stack. And this is Old Harry's rock. This is his wife. If that stack continues to erode, eventually it's going to leave behind a stump. So the correct sequence is crack, cave, arch, stack, stump. And there it is. Okay, so you have a crack, which forms a cave, which forms an arch, which forms a stack, which forms a stump. And remembering all the time to get those erosional processes in there. That's all the erosional landforms that students need to know about. This is a depositional landform called a spit. Okay, and the best way to show you this one is here. So we've got our original coastline, and we talked about longshore drift earlier. So sediment moves in via the swash and backwash because of the prevailing wind, swash, backwash, all the way along the coastline. You can see here the coastline changes direction. And earlier we said that's one of the reasons why the waves deposit their sediment. So as the longshore drift continues, okay, it loses its energy and it starts to deposit its sediment, building up this sand spit. Sandbanks is another example of one of these. Over time, a salt marsh will form behind the spit because it's sheltered. So on this photo, there's a salt marsh down here because it's sheltered from the waves, okay? Great for sort of bird watching and all that sort of thing. And eventually as well, the spit can change direction. Okay, we call this a curved end or a hook spit, and that's because the wind direction might change as well, all right? If this spit was to extend all the way to the end here, it would become a bar, and we would have a lagoon trapped behind it. Chesil Beach in Weymouth is an example of this, okay? But what's stopping this one extending is it has a river here. So again, back to this photo, there'll be a river, okay, coming out here, and that's going to push any sediment out here. You can see the sediment in the water. So if this spit was to extend here, which it won't, it would become a bar, and this would be a lagoon, okay? But a river is pushing any sediment out there and stopping that from happening. Okay, that's pretty much it. So what I would advise you to do at this stage is kind of rank order how well you know those landforms, headlands and bays, wave cut platforms, stack/stumps, and a spit. Remember, these three are erosional landforms, and this is a depositional landform. And if you want to have a go at a question, with use of a diagram, explain the formation of, and then choose the one you're not as confident on. Okay, if you want any more help on this, just get in contact. I've got some great other resources as well. Lovely. Well, have a great day and get ready for the next video, which is looking at coastal management.